Hello, and welcome to this podcast from The Knowledge Study. My name is Alexander Martinez-Kochman, and this is the first in a series of podcasts talking about supply chain management topics, including the role of technologies in the next generation supply chain, which I personally find a fascinating topic. Today I'd like to spend a few minutes talking about blockchain-driven supply chain integration in general. Blockchain is the underlying technology behind cryptocurrencies, and it's been enjoying a hype for a while. But beyond what is arguably the most popular application, cryptocurrencies, the use of blockchain in the supply chain is receiving increased attention because of the tremendous potential it can offer in terms of business models, efficiency, trust, and customer satisfaction. Later we'll see some examples, but let's start first with some very basic blockchain concepts. Blockchain is a decentralized encrypted database that acts as a ledger, recording a permanent record of all the transactions that have taken place in a secure, chronological, and immutable way, based on a consensus protocol. The great thing about blockchain is that it's not only about transactions going back and forth, but that the concept also includes smart contracts. Smart contracts are autonomous programs running across the blockchain network that express triggers, conditions, states, and business logic to enable complicated programmable transactions. Smart contracts can be used to automate supply chain processes, trigger actions in and outside the blockchain based on business logic. For example, invoicing based on work completion, trigger updates for supplier forecasts, manage contract entitlement for service requests, tracking the installed base of an industrial ecosystem, managing service level agreements, or managing product life cycles and provenance. In your typical public blockchain, like Bitcoin, a block is essentially a container for transactions. First, a number of transactions that are pending validation are gathered into a block by one of the nodes in the network. Then the block is mined, which is the process whereby nodes on the blockchain compete to see who first solves a complex mathematical problem. Whoever does it first gets consensus from the other nodes in the network. This is called proof of work, and then the block is added to the blockchain. Each block is linked to the previous block in order to preserve the integrity of the chain. One important observation is that mining is not part of enterprise blockchains, which are private blockchains. Mining requires very high power consumption due to the extraordinary computing power needed. Enterprise blockchains are private, which means that participants require permission to operate on the blockchain, and the validation of transactions is carried out by a very limited number of nodes. Now let's have a look at some examples of how enterprise blockchains are being tried. Examples include tracking groundwater use, tracking and validating home healthcare services, improving the transparency of clinical trials, providing consumers with visibility of the complete food supply chain, tracking the life cycle of parts used for manufacturing, tracing pharmaceuticals to prevent fraud, or sharing vehicle mileage with interested parties. There are important consortia where companies collaborate. Hyperledger is a good example. Hyperledger is an open-source collaborative effort created to advance cross-industry blockchain technologies. It is a global collaboration hosted by the Linux Foundation that includes leaders in finance, banking, Internet of Things, supply chains, manufacturing, and technology. When considering the application of blockchain to supply chain management or supply chain integration, we need to consider a number of realities. Supply chains evolve organically and through acquisitions, therefore bringing different supply chains together. Over time, supply chains end up with legacy systems that are vital to the operation and whose replacement represents a big operational risk that companies are tempted to avoid until there is no other alternative. Companies constantly evolve and reorganize for efficiency or business strategy reasons, resulting in changes that can impact many different aspects of the organization. It is not unusual, especially for bigger companies, to have an heterogeneous IT ecosystem, with loosely connected solutions that follow different product life cycles, require complex multi-system integration, and result in segmented master data. Changes in the market, organization, and systems can lead to a limited process alignment and adherence within a company or a supply chain. Today, more than ever, confidentiality and security are key. A lot of the data in a supply chain is sensitive, not only internally, but also any customer and third-party data required to manage the supply chain. And last but not least, shareholders demand results, so important changes to the systems and processes on which supply chain operations rely require executive buy-in and a solid justification for significant investments or any operational risk. By using blockchain integration, in effect, what we are aiming to establish is a common platform for supply chain transactions, smart contracts, and data analytics. This platform will enable seamless, secure, permissioned, and validated information sharing and business logic execution for all supply chain stakeholders. This is in most cases, and especially for big companies with multiple systems and an international presence, a challenging task, and one that should logically start with a proof of concept. One possible approach is as follows. First, we need to understand where a blockchain solution could bring the most benefit, based on our knowledge of the supply chain and the basic characteristics of enterprise blockchains. We then need to investigate blockchain solution providers and perform a selection process. This process must be driven by key challenges that we're looking to address in the supply chain, in combination with the blockchain solution provider's capabilities. Based on the review process and the blockchain solution functionality, we can then fine-tune the scope of the proof of concept and define the supply chain segment or flow where it could be tested. During execution, we could establish the selected parallel flows outside standard operations and the mechanism to simulate external triggers and any off-chain information flows with other systems in the supply chain, such as order management, inventory management, or invoicing. Finally, we determine what efficiency improvements might have taken place, any observed process gaps, the quality of the information flow, and we evaluate the adaptations to the solution and/or the supply chain that might be required. From a supply chain perspective, this means to processes, systems, organization, or master data. These changes would be required if we were to consider industrializing the proof of concept for the chosen portion of the supply chain. Should a proof of concept prove successful, there is an even more challenging road ahead, but we can leave that for another podcast. Thank you for listening. I hope you found this podcast useful, and if you're interested in hearing more about any of the concepts we covered, please leave a comment. Thank you again, and see you next time.